Welcome back, kids. Today's video lecture is about tutorial number 1 of the EMF course. In this video lecture, we will see the different problems which I have asked for you in tutorial number 1, and we will try to solve them one by one. In the first question, see the first question here. See, there have been given 3 points. Convert points P, T and S from Cartesian to cylindrical and spherical coordinates. So it seems that these 3 points are given in Cartesian coordinate system, and you are supposed to convert them into either cylindrical or spherical coordinate systems. Now let's see how we can do these things step by step. Now we will try to convert each of these points into cylindrical coordinate system first of all. So we know that from Cartesian to we'll try to convert first from Cartesian to cylindrical coordinates. We know the formula of how to convert the Cartesian coordinates into cylindrical coordinate systems. Let us suppose if x, y, z they do represent Cartesian coordinates, and r, phi and z they represent cylindrical coordinates. So the conversion is very simple. R is equal to square root of x square plus y square. Phi is equal to tan inverse of y by x. And z is equal to z. And whenever you are computing phi, we are supposed to take care of the x and y coordinates, whether they are positive or negative. Okay. So first of all, we will start with the point number P. 1, 3 and 5. See, these are x, y and z. So the r value is square root of x square plus y square. So it is square root of 1 square plus 3 square. It is root 10. And the phi, tan inverse of y by x. So it is tan inverse of 3 by 1. So it is tan inverse 3. And z remains the same. So the final answer is phi p in terms of cylindrical coordinates is root 10 comma tan inverse of 3 comma phi. You are supposed to mark here the angle which is there for tan inverse of 3. And now the second question, now if you carefully see, it is t 0 comma minus 4 comma 3. So it is again x, phi and z. So r is equal to square root of 0 square plus minus 4 square. It is 4. Phi is equal to, see, this is cos is positive, this is negative. So which means if cos is positive and sin is negative, then see, you know the quadrant system, right? Here both x and y both are positive. Here x is positive, y is negative. Here x is negative, y is negative. Here x is negative, y is positive. See, x and y. So this point is lying in 4th quadrant. When you are lying in 4th quadrant, you must take minus tan inverse of, you consider only the magnitudes here, 4 by 0. Minus tan inverse of infinity, it is minus 90 degrees. And z is equal to 3. So the points are 4, minus 90 and 3. So whenever you are getting these different types of situations, particularly for computing phi, how to compute phi? For first quadrant, you directly take tan inverse of mod y by mod x. For second quadrant, you take pi minus tan inverse of mod y by mod x. For third quadrant, you take 5 plus tan inverse of mod y by mod x. And for fourth quadrant, you take minus tan inverse of mod y by mod x. Okay. So this is the way how you are supposed to employ the equation for phi based upon your quadrant operation. Okay. Now the third point, S. See here, S is equal to, it has given as minus 3, minus 4 and minus 10. So R is equal to square root of minus 3 square plus minus 4 square. It is 5. Phi, what you will get, since it is, this is negative, this is negative. So what is the equation? This is the equation, right? 5 plus tan inverse of mod y. It is 4 by mod x. It is 3. So what are the angle which you will be getting? You are supposed to write down here. You will get somewhere around 235, I think so. Okay, and z is equal to minus 10. So the coordinates are minus 3, sorry, plus 5, 235 degrees and minus 10. This is the representation of the coordinate system in cylindrical coordinates. Now we will move on to spherical coordinates now. Coming to spherical coordinates. Now we know that conversion from Cartesian to spherical systems. How to convert from Cartesian to spherical coordinates? Let us suppose Cartesian systems are given by x, y, z and spherical systems are given by r, theta and phi. So how to convert between these two? So we know that r is equal to square root of x square plus y square plus z square. Theta is equal to cos inverse of z by r. And phi is equal to tan inverse of y by x, and we will apply the same formula. What we are supposed to do, either if both are positive, we will directly take tan inverse of mod y by mod x. If it is second quadrant, pi minus tan inverse of mod y by mod x. If it is third quadrant, it is pi plus tan inverse of mod y by mod x, and if it is fourth quadrant, we will take minus tan inverse of mod y by mod x. Now we will start with first point. It is p1 comma 3 comma 5. So r is equal to square root of 1 square plus 3 square plus 5 square. So you will get somewhere around square root of 35. So, sorry, I am supposed to represent as capital R. Yeah. And next, theta is equal to cos inverse of z by r, which is cos inverse of z is 5 by root 35. Phi is tan inverse of 3 by 5. Both are in first quadrant. See, both are positive. So first quadrant, I will directly write it as, sorry, 3 by 1, right? Tan inverse of y by x. So it is tan inverse of 3. So what is the answer? Root 35 cos inverse of 5 by root 35 and tan inverse of 3. You are supposed to write the values of these two. Okay. Next is t at 0 comma minus 4 comma 3. For this point, r is equal to square root of 0 square plus minus 4 whole square plus 3 square. It is 5. Theta is equal to cos inverse of z by r, it is cos inverse of z is 3 by r is 5, and phi is equal to tan inverse of y by x, so minus 4 by 0, right? So since it is in, this is negative, sorry, this is positive, this is negative, which means that it is in fourth quadrant, so I will take minus tan inverse of mod y, so it is plus 4 by plus 0. So it is minus tan inverse infinity, it is minus 90. So the answer is phi cos inverse of 3 by 5 by minus 90 degrees. Okay, next is yes. So yes, it is minus 3, minus 4 and minus 10. So r is equal to square root of 3 square plus 4 square plus 10 square. It is square root of 125. Okay. So it is 5 root 5, I think. And next is theta. It is cos inverse of minus 10 by 5 root 5. You will get some value. And phi is, see, both are in negative, so you will get pi plus tan inverse of 4 by 3. So the value is 5 root 5 cos inverse of minus 10 by 5 root 5, and this is pi plus tan inverse of 4 by 3. These are the values. Cylindrical coordinates for your given 3 points. Okay, so I hope that you can solve these problems if asked for short answer questions. Thank you. We'll see the next problem now. Okay.